Earth Expeditions, an in-depth look at how NASA studies Earth beyond satellites. The view from space gives us a global picture, but we go closer to the ground to get a granular view of what's going on by using ships, aircraft, ground stations, and our own eyes. We call these closer looks field campaigns. NASA has a long history of field campaigns. Just in the past months, NASA scientists have been all over the world, from the glaciers in Greenland, to the forests of South Korea, to the crashing waves of the North Atlantic. We're getting the data that is revealing the secrets about our changing planet.
Aloha, and welcome back to NASA's Earth Expeditions. Today we're going to Hawaii to study one of the most exciting and dynamic parts of the Earth system, coral reefs.
They're a source for food, medical advances, tourism, and they're amazing. Hard corals have actually outlived dinosaurs.
Now, if you search online for images of coral reefs, you probably think we know a lot about them.
We simply don't have enough data to understand which impacts to reefs are the most damaging.
And that makes it impossible for us to figure out how reefs are going to change in the future.
So that's why we're sending out NASA's mission appropriately named CORAL, the Coral Reef Airborne Laboratory.
Coral will look at how reefs are responding to change going on in our oceans right now, with teams high in the air and divers down in the ocean.
To learn more, let's hear from Michelle in Hawaii.
Hey everybody, my name is Michelle Girak and I'm the project scientist for the Coral Reef Airborne Laboratory, or CORAL mission. Right now we're at Air Surfaces Hawaii with the heart and soul of the CORAL mission, which is the Tempest Applied Solutions Gulfstream 4, or G4. What makes this aircraft so important to CORAL is what it has inside the plane is the portable remote imaging spectrometer, or PRISM instrument, and it sees through the bottom of the plane to assess coral reef condition at 28,000 feet above the ocean's surface. We are in Hawaii as part of one of our field campaigns, specifically our operational readiness test, in which we have an in-water team in Kaneohe Bay taking observations. We'll have the G4 flying over, collecting observations. The two together provides an indication of what the coral reef condition is within Kaneohe Bay. And this is sort of the nexus of coral, the in-water with the aircraft, to give a better understanding of what are our coral reefs currently undergoing and how will they change with respect to climate.
So this mission is going to help us understand corals a lot better than we know right now.
Yeah, and I think something people need to realize is that though corals are dynamic features, they can shrink and grow just under natural things, the forcings happening to the Earth's climate right now, they're causing massive changes. And we need to understand how they're really connected up to the corals. And that's why the coral mission is so important.
So earlier we actually did another mission, Oceans Melting Greenland, to measure glaciers in Greenland. So how is coral and these glaciers in Greenland similar?
Yeah, so think about it. The ocean is one of the most powerful components of the Earth system. It stores a lot of heat. And in the case of oceans melting Greenland, or even understanding the reefs, we're doing a combination of things. We got these satellites going across the sky, taking pictures, looking down. And then we have our airplanes, and the airplanes are going across at a lower level, and they're doing things like in ocean melting Greenland. They're actually dropping little sensors into the ocean that actually put a string out to understand the temperatures and the composition. But then for all these missions too, we put people right down in the water in boats, we put people over the side, and all this stuff has to come together in concert to help us really understand the Earth system.
Right.
Even computer models at the end of the day, which is what we put all this stuff into.
Yep. So say you're a young person in high school or college and you want to learn how to be a scientist involved with these missions. How does NASA help?
NASA is all about STEM education. Science, technology, engineering, and mathematics are the basis for what NASA does. So we have programs like the NASA Student Airborne Research Program that help get the career ball rolling. Let's hear from Emily out at NASA's Armstrong Flight Research Center in Palmdale, California for more details.
Hi, I'm Emily Schaller, and I'm the project manager for a NASA summer internship called the Student Airborne Research Program, or NASA SARP. I'm here at NASA Armstrong Flight Research Center in Palmdale, California. As you can see, this is a massive hangar for NASA's flying laboratories, including this plane, the DC-8, which is used for Earth science research all over the world. 32 students from 32 different colleges and universities from across the United States just flew on board the DC-8 over Southern and Central California. SARP is an opportunity of a lifetime. Students get an end-to-end, hands-on research experience in all aspects of an airborne Earth science campaign. They have the opportunity to work side by side with NASA scientists, pilots, and engineers. This year, students are collecting data with a suite of instruments used by the recently completed Korea-US Air Quality Mission, or CHORUS-AQ. Students help operate scientific instruments in flight in conditions not typically flown on commercial aircraft. Students also collect data at ground sites in California and along the coast. In addition to the DC-8, students will also use airborne imaging data collected from the NASA ER-2 high-altitude research aircraft. By the conclusion of the program, each student develops an individual research project from data collected in the air, on the ground, and from satellites. The goal of SARP is to train the next generation of Earth system scientists and engineers. Many SARP alumni have gone on to participate in other NASA airborne research missions, and some have even come back to SARP as mentors. The Student Airborne Research Program wraps up in Irvine, California in August, but for many of these students, this experience could launch their careers in Earth system science.
One of the challenges in becoming an Earth scientist is that it's not a career opportunity that a lot of people even know is out there. So we run programs like SARP to get young people engaged. Education is important and so is field research, but to get out in the field and be a part of a research team, you have to have adaptation skills and you have to know how to ask for help in those difficult situations. And sometimes in an airborne mission, you may find yourself without an airplane.
Every year, you start out with zero. 0 miles flown, 0 data collected. This year, Icebridge started out with yet another big zero. There were no aircraft available for the mission, as NASA's decades-old P-3 was getting re-winged. So the team turned to their friends at NOAA for help. And they got Miss Piggy, another P-3 aircraft and a veteran of 88 hurricane missions from Floyd to Francis to Katrina. Operated by a crack flight crew ready to tackle the far frozen north for the first time. After installing Icebridge's many instruments into the aircraft, performing needed maintenance, and flying a few test flights over Tampa Bay, the Icebridge team was finally ready to go. The team's first target was to take measurements of sea ice in the Arctic Ocean, and after a few weeks, Icebridge had achieved solid coverage of the western Arctic basin, and on one mission, even grazed the North Pole itself, coming within 200 meters of the top of the world. From there, the mission changed its focus to northern land ice, and after waiting days for the fog to lift, finally managed to hit a crucial target, the Zachariah Istrom. This massive glacier drains 5% of the Greenland ice sheet, and in 2012 entered into a phase of rapid retreat, making repeat measurements all the more crucial.
Planes in the air and coral in the sea.
Glaciers in the ocean and aerosols in the air.
Satellites and divers.
Scuba divers and firefighters.
Ancient maps and modern marvels.
You're winning. This is really hard now.
It was your idea to have the map, so.
It was my idea to have the map.
Anyhow, NASA Earth Expeditions. Your planet is changing and we're on it.
Kick it, DJ. Yeah, I got you.
Sorry.
I got you. We're gonna, yeah, we got it.
All right.
And
All
let's
right.
try and do alliteration. Oh, this will be a fun game.
3,
Yeah.
2, 1.